Hey everyone! After talking about combining like terms, we're ready to start with the bread and butter of this part of the unit, the properties of equality. Whenever you're presented with an equation with a bunch of x's in it, you must wonder, how do I solve this? Well, in some cases you could probably guess, but that's not always reliable, especially when you have negatives and decimals in the mix. It's not always the most number one thing you should go after. However, there is a number one way to manipulate an equation in order to find a solution. We're going to work our way from the simplest kinds of equations all the way to the most difficult. But first, we need to know how to manipulate these things. We can't just move things around willy-nilly. You can't just move one thing around in your house without moving something else, and that's the same thing with equalities. So let's see how that works. But one thing I got to review real quickly first is inverse operations. Inverse operations are the opposite operations that cancel one another out. So they're operations that cancel one another out. So it's kind of like saying that plus and minus are the opposites. Because after all, with any two terms that are opposites, as we saw previously, they cancel. For example, 5 minus 5 is just 0. X minus x, also 0. This works out because 0 is basically the neutral factor here. And the same thing works for multiplication and division. These are also opposites. Because when you multiply, this works a little bit differently. Because when you multiply, say, 2 times 1 over 2, you'll get the answer as 1. 1 in this case is the multiplicative and dividative. I think that's the word. I really don't remember. That's the neutral element right here. Or basically the 0. So whenever you're multiplying or dividing, make sure you do the opposite. Whenever you're adding or subtracting, also do the opposite. All right, so I'll leave a comment right here. I'll leave it in another color. Each are opposites of each other, which is the easiest way to understand inverse operations. And that's going to come into practice later. All right? The next thing we really need to see is that when we have an equal sign, it's like a balanced scale. All right? So what that means is, if you're thinking of it like a scale with two things on it, the fulcrum right here, there's the same amount of stuff on both sides. So I'm going to mark right here, same stuff. And that's what keeps everything so balanced in the world. The only reason we're not falling apart is because one side has the same amount as the other side. Kind of like a yin-yang relationship. So we can't just add things to the left or multiply the right side without changing something on the left. And that's the exact logic we use when it comes to equalities. So basically, we can't change one side without changing the other. More specifically, we can't change without changing the other by the same amount. By the same amount. So I can't just add 5 raisins to one side and 5 bowling balls to the other. You'll crush my head, dang it, don't do that to me. So how does that work? So whenever you have an equal sign, which is basically what this balance is trying to represent, you have to do the same operation to both sides. So that's where we come with the properties of equality. Properties of equality. The superheroes that keep things in balance. That keep things in balance. And there are 4 of those properties we're going to take together. The first one is that we can add to both sides. Note that we can't do this to only one side or the other. So in this case, when it comes to adding to both sides, let's take an example here of, say, x minus 5 equals 8. If I want to add to both sides, I'll do that in blue. I want to add 5 to both sides. Note that I have to do this to both, not just one. I have to add 5 to both of them. And then I can add to both sides, and we still have perfect balance. And if you do this, you'll find that x equals 13, which works out for this equation. we're already kind of getting ahead of ourselves, and that's pretty natural in a case like this. But the big thing I want to demonstrate right here is the adding of 5. Another good thing to note is the dotted line I just put there. I'm going to put right here as a hint. The dotted line is good practice. That'll become relevant later, once we start dealing with more complicated equations, but let's stick with what we have for right now with one more example with adding. So let's say x minus 25 equaled 1. In this case, once again, we can add to both sides by 25. Why am I picking 25 is something we'll see later. The logic behind it, you might already be able to see it. But we'll talk more about it in our next lesson when we start talking about one-step equations, which we kind of are already seeing right now. But in short, the takeaway from this is that we can add the same term to both sides. I'm going to add this little comment right here, the same term, to both sides to maintain equality. The next one right here, you can probably guess. As the opposite of addition, we can subtract the same term from both sides. Capitalizing that both because we can't just do it to 1. And as soon as I'm thinking about it, I'm thinking of 1. No, I should be thinking of the whole. Dang it. So here, if I had a case like x plus 2 equals 7. So in this case right here, if I want to subtract 2 from both sides, that's the case where I am taking away 2, and it has to be from both sides. In this case, I'll be left with x equals 5. Similarly, what if I had x plus 30 equals 15? Once again, I can subtract 30 from both sides, and we still have balance. The way you can check this is by replacing x by its value, and you'll see that we're getting a value that actually works here and satisfies the equation. For x equals 5 here in this one, x plus 2, or 5 plus 2, does indeed equal 7. Or in here in this case, for x equals negative 15. Negative 15 plus 30, that's 15. And the same thing can apply for the addition ones. And you can check that for the rest of the problems as well. For now, let's move on to the third property. We've done addition, we've done subtraction. It only makes sense to move on to the next logical one, pi throwing. And by that I mean multiplication. So we can multiply both sides by the same number. Or the same term, I should be more specific. All right? That usually manifests when we have division. But keep in mind that division is oftentimes in algebra represented with fractions. So I could have something like x over 5 equals 6. In this case, I could multiply both sides by 5. Now, a quick little fraction review right here, because this often confuses students. If I had 1 over 5 and multiplied that by 5, remember cross-canceling. And that's where I can find a common factor between one numerator and another denominator, which in the case of the 5s is just 1. And boom, we now have the multiplicative neutral. In this case, I am left with just x equals 6 times 5, 30. That's the logic I'm using right here. And I'll show you one more example with x over 2 equals negative 9. Once again, the logical step here is to multiply by 2. I'll be left with x on one side and negative 18 on the other. Once again, you can double check these answers to see if the x values do work. And we'll talk about that logic in the next lesson when we start one steps. Finally, we got one more left, which is table flipping. Or it's just getting an extra water, because I desperately need that right now. Nah, I'm kidding. I'm done kidding. It's dividing. Divide both sides by the same non-zero term. A green card to anyone who can specify why I said non-zero here. To anyone who knows the logic behind why that had to be specified. Again, division is often the opposite of multiplication. So usually if I have something like 3x equals 18, I can cancel that out by dividing both sides by 3. And we left with x equals 6 in this case. 18 divided by 3 leaves us with 6. And finally, one more left. Keep in mind that we can multiply and divide by negative numbers if we need to. So in this case right here, let's say negative 4x equals 28. I can divide both sides as well by a negative number. Here, not by negative 7, sorry, I'm getting ahead of myself, by negative 4. Here I'm going to be left with x equals negative 7. We'll talk more about the logic behind the negatives later, but for right now, these are the 4 properties you need to worry about. Adding terms to both sides, subtracting terms to both sides, multiplying to both sides, and dividing both sides by a non-zero number. So basically, the recap, we can add, subtract, multiply, or divide both sides by the same term. And the logic that we're going to use to do this, well, that's what we'll see in our next lesson. Until next time, Algebros.